in simple microscope, we use convex lens and single convex lens. We also say this is magnifying glass. So in this case, object is placed over here and image is forming at same side of object at distance d from the object, and that distance d is 25 centimeter. It's a most clear vision for human eye. Now if I want to find out magnification of this one, so I can write 1 by v minus 1 by u is equal to 1 by f, and we can also write 1 minus v by u is equal to v by f, just multiply by v, and in that case v by u, that should be equal to 1 minus v divided by f. And we know this v by u is magnification, so this thing is magnification, so m is equal to 1 minus v divided by f. And if image is forming at 25 centimeter, means this is the image. So in that case, what is v? V for this one is minus d. So in that case, magnification we can write m is equal to 1 minus d divided by f. It means magnification is equal to 1 plus d by f. So for simple microscope, if image is forming at distance 25 centimeter from the lens, in that case we can say magnification is 1 plus d by f. More focal length, less magnification, less focal length and more magnification. What happens? This image is forming at infinity. Means this image is not forming at 25 centimeter. Let's say this image is forming at infinity. So if this image is forming at infinity, in that case what happened? You have to put this object on the focus. Means this length should be the focus of a lens. So to find out magnification in this case, what we use? Just we put object over here at a distance d without using any lens as a naked eye. We are looking object in naked eye. In that case, we are not putting any lens over here. In that case, what is angle theta naught? Theta naught we can write h divided by d. And if I using this optical instrument, means I am using this microscope, in that case that angle made by this object is theta. See, object is this one h. Here also object is h. This object h making angle theta naught if you are not using lens. And if you are using lens, in that case this object is making angle theta. So if I calculate this theta, so theta should be equal to h by f. Why h by f? Because image is forming at infinity. We are taking image as forming at infinity. So h by f. So in that case, how to find out magnification? Magnification is equal to theta divided by theta naught. And if I calculate this theta divided by theta naught, that will be equal to d by f. So we got two formula of magnification. One, m is equal to 1 plus d by f. This is the formula when image is forming at distance d. And we got another formula, m is equal to d by f. And this is the formula when image is forming at infinity. And we also say this one is normal adjustment. This is normal adjustment. Normal adjustment means image is forming at infinity distance. Now, disadvantage with simple microscope, we can only magnify object till 4 times. So if I want to magnify object more than 4 times, so we have to use another microscope, that is called compound microscope. In compound microscope, we use two lenses. First lens we say it objective lens. This one is objective lens. Second lens we say this is eyepiece. So we are using two convex lens. Second one towards eye, whatever lens is there, that is eyepiece. And towards object, whatever lens is there, that is objective. Now object is placed over here. So this is the object. And image of this object is forming at distance, some distance, and that is a dash b dash. Now this a dash b dash, this image formed by first object, first lens, it will work as an object for second lens. It means final image will form at distance capital D. So with the help of two lenses, we are trying to magnify this image multiple times. We can say this is the object and this is the final image. So there is a more magnification. So in case if you want to magnify image more than 4 times, in that case we have to use two lenses, and this combination of these two lenses we say it compound microscope. So in compound microscope, if I want to find out magnification, so magnification will be equal to H double dash divided by H. H double dash is what? Final image, and H is what? Initial object. So this is the magnification. We can rearrange this one, H double dash divided by H dash, and this one is H dash divided by H. Now you can see that this is H dash and this one is H. So H dash divided by H, that is magnification of objective. H dash divided by H, that is magnification of objective, and H double dash, this one, H double dash and H, this is the magnification of a eyepiece. So you can write magnification is equal to magnification of eyepiece into magnification of objective. So magnification of objective into magnification of eyepiece, exactly same thing. So magnification of objective, I can write V naught divided by U naught, and magnification of eyepiece, that is D divided by FP. Previously we have done this one in case of a simple microscope. So this is the magnification. When this magnification formula work? When image is forming at distance D. This is the image. What happens if this image is forming at distance infinity? If image is forming at infinity, in that case what will happen? That M is equal to MO into ME. MO will remain same, that is VO divided by EO. But what will happen to ME? That become D upon FE. So there are two formula. This formula used for normal adjustment when image is forming at infinity, and this formula is used when image is forming at distance 25 centimeter. See, telescope is used for bigger object, and we always try to see the long distance using telescope. It means practically object distance for telescope is infinity. So this is the diagram for telescope, and image by first lens is forming at this point AB, and this AB work as an object for eyepiece, and final image is forming at distance D. If final image is forming at distance D, in that case if I want to calculate magnification, so magnification is equal to beta divided by alpha. We can write beta divided by alpha. What is beta? Beta is angle made by the object, angle made by this object when we are using lens. And what is alpha? Alpha is angle made by object when we are not using any lens. You can see left hand side there is no lens. Left hand side of first lens there is no lens. It means alpha is the angle when we are not using any lens, any optical instrument, and beta is the angle when we are using optical instrument. So this will be the magnification. So we can write beta is equal to H divided by UE, and alpha is equal to H divided by FO, because image formed by first one is at distance FO. So this is FO. So we can write beta is this one, this angle is beta, and this distance is UE, this one is H. So beta is equal to H divided by UE. Now we can write this one, this distance is, now this distance is FO, and this one is H, and this angle we can see that is alpha. It means alpha is equal to H by FO. So if I find out magnification, so that will be FO divided by UE. So this is the magnification. Now if image is forming at distance 25 centimeter, here image is forming at distance 25 centimeter, it means I can replace this one 1 by UE. How we can replace in 1 by UE? 1 by VE minus 1 by UE is equal to 1 by FE. As 1 by UE, we can write 1 by FE minus 1 by VE. And VE is equal to, in this case, V is equal to minus D. So simply what I can write, 1 by UE is equal to 1 by FE plus 1 by D. And if I solve this one, 1 by UE, that will be equal to D plus FE divided by FE into D. So if I substitute this value over here, so finally what I'll get, M is equal to FO divided by UE and minus 1 by UE, that is FE plus D into FE into D. So magnification will be equal to minus FO FE plus D divided by FE into D. Now if I simplify a bit this one, so I will get FO divided by FE, and that is 1 plus FE divided by D. So this is the magnification of a compound this is the magnification of a telescope. Now in this case, where image is forming? Image is forming at distance D. Now if image is forming at distance infinity, in that case magnification formula M is equal to FO divided by UE, and if I put value of UE, so that value of U will be minus value of UE will be minus FE. In that case, what will be magnification? Minus FO divided by FE. It means if image is forming at distance D, this is the magnification formula. If image is forming at distance infinity, so this is the magnification formula. Length of this telescope pipe, this one, that is L is equal to FO plus UE, and in case when image is forming at distance D, and length will be FO plus FE if image is forming at distance infinity. We are using a reflecting telescope. In reflecting telescope, use mirror. In this case, magnification is minus FO by FE. So magnification of this one is also minus FO by FE. It work on same principle. Object is at infinity and image is also at infinity. So magnification is FO by FE. Scope pipe, if you can see. Now there is another telescope that is called terrestrial telescope. In this terrestrial telescope, this is FO, this is 2F1. We are using 3 lenses. So this is eyepiece, this one is objective, and this lens, this lens is middle lens, erecting lens, F1. So why we are using this one? You can see before that all images formed by telescope was inverted. Now if I use one extra lens, in that case image will be erect. So that is the use of this one, this third lens. So whatever telescope I used, magnification was negative. In that case image was inverted. But now if we are using 3 lens basically, if you are using 3 lens, then magnification will be positive. And if I want to find out length of this pipe, so length of this pipe will be equal to FO plus FE plus 2 times of F1. The focal length of objective and eyepiece, that is 4 mm and 25 mm respectively. Length of tube's length 16 cm. If the final image is from infinity and least distance of distinct vision 25, then they calculate the magnifying power of microscope. You can see that final image is forming at infinity. It means I have to use this formula, M is equal to V0 divided by U0, that is D by F. That's it. Now V0, okay, if final image is forming at infinity, in that case if you see that UE will be equal to 2.5, just equal to focal length, and VO will be equal to 16 minus 2.5, so that will be equal to 13.5, and value of D, that is 25 centimeter. And if I use this formula, value of D 25 centimeter. Now if I use this formula, 1 by VO minus 1 by UO is equal to 1 by FO. Now 1 by VO is equal to 13.5 minus 1 by UO is equal to 1 by FO, and FO value, focal length of a objective, is 4 mm, so that is 4. It means UO, if I calculate, that is equal to 54 divided by 131 centimeter. So after calculating UO, magnification formula is what? Magnification formula is V0 divided by U0 and D divided by FE. So if I substitute value, so that is equal to minus 13.5 divided by 54 divided by 131 into 25 divided by 2.5, and if I solve this whole thing, we are getting 327.5. so this will be the magnification of a microscope. Now there is one question based on telescope. The telescope and objective lens focal length 50 cm and eyepiece of focal length 5. The distance of distinct vision 25 cm, and telescope is focused and distinct vision 200 cm away from the object. It means they are asking for separation between objective and eyepiece. It means they're asking L is equal to VO plus UE. This thing they are asking. So UO is given, that is minus 200, and FO is given, that is plus 50. And if I use this formula, 1 by VO minus 1 by UO is equal to 1 by FO. In that case, 1 by VO minus 1 upon minus 200 is equal to 1 by 50. And if I calculate VO, that will be equal to 200 divided by 3. Now, 200 by 3 is VO. Let's say separation is X. So UE will be equal to minus X minus 200 by 3. Now we got UE. VE, that should be equal to minus 25 centimeter, and FE is equal to plus 5 centimeter. Now I use formula 1 by VE minus 1 by UE is equal to 1 by FE. Just I have to substitute this value, and after substitution I'll get 1 by 25, and this one will be plus 1 upon X minus 200 divided by 3 is equal to 1 by 5. And if I solve this whole thing, I will get X is equal to 70.80. So this is the separation between this one. And they are asking magnification produce. So they are asking magnification produce. So magnification, for magnification, what we can do? M is equal to M1 is equal to V0 divided by U0. V0 is given. How much? We calculated V0. V0 value how much? That is 200, and U0 is equal to 200 by 3. To calculate magnification, what we'll get? V0 is equal to 200 divided by 3, and U0 is equal to 200. So if I solve this whole thing, so I will get M1 is equal to 1 by 3. And M2, we can use M2 VE divided by UE. We calculated VE. VE is equal to how much? That was minus 25. And UE, we calculated it. UE value how much? We can calculate UE value, and UE value is how much? 25 by 6. That will be 25 by 6. If I calculate UE using this formula, UE, if I calculate this one, so that will be 25 by 6. And if I solve this one, so I will get magnification 6. So M2 will be equal to 6, and M1 is equal to 1 by 3. So total magnification M is equal to M1 into M2. So that is equal to 1 by 3 into 6, that will be 2. So this is the final magnification. Next, a compound microscope used to enlarge an object kept in distance 0.03. Object which consists of several convex lens of contact focal length 0.1. If the lens focal length 0.1 meter is removed from objective, find out the distance by which eyepiece microscope must focus to reform the image. So in this case they are using several lens, and if several lens they are using, where will be VO? First I calculate VO. So 1 by VO minus 1 by UO is equal to 1 by FO. Now UO is given. UO is 0.03 meter, and FO is also given. FO is equal to 0.1. FO is 0.02. Now if I use this formula, 1 by VO minus 1 upon minus 0.03, and FO is equal to 1 upon 0.02, and if I solve this one, I will get VO is equal to 6. Now I calculated VO. Now they remove one lens, so combination focal length, new focal length will be 1 by FO dash is equal to, this is the combination focal length minus 1 by 10, because after removing that 0.1 meter is reduced. So minus 0.1 by 10, we are using in centimeter. So if I calculate FO dash, so that will be equal to if I calculate FO dash, so that will be equal to plus 5 by 2 centimeter. I got FO dash now. Now I can use this one, 1 by VO dash is equal to 1 by UO plus 1 by F0 dash. Now I substitute value of this one, so that is 1 by 3 minus sign plus 2 by 5, and if I solve this one, that will become 1 by 15. So 1 by VO dash is equal to 1 by 15. It means VO dash is equal to 15. So VO dash is 15. Initially VO was how much? 6. So how much it's shifted? 15 minus 6, that will be 9. It means 9 centimeter we need to shift that microscope thing. So 9 centimeter shifting will be there. Answer for this one will be 9. In compound microscope, objective focal length this one are kept in distance 20 centimeter, and final image is formed distance 25 centimeter from there. Calculate the position of object and total magnification. So they are saying that VE is equal to minus 25 and FE is equal to plus 5. Now I have to calculate UE. So 1 by VE minus 1 by UE is equal to 1 by FE. Now 1 by VE minus 1 by UE. 1 by 1 divided by minus 25 minus 1 by UE is equal to 1 by 5, and if I solve this one, I will get UE is equal to minus 25 by 6. Now UE is given, so VO will be equal to total length minus UE, mod value of UE. So that will be 20 minus 20 by 6, that will be equal to 95 divided by 6. Now I got VO, and FO is already given, that is 0.95, and if I solve this one, 1 by VO minus 1 by UO is equal to 1 by FO. Substitute value simply, so I can find out UO from here. So 1 by VO how much? 95 by 6 minus 1 by UO, and FO is 1 upon 0.95, yes, 0.95, and if I solve this whole thing, so UO will be equal to 95 divided by 94. And they are asking for magnification as well. So for magnification, I will use formula VO divided by UO 1 plus V divided by FE, and VO value is known. We calculated, that was 95 divided by 6. UO value, that will be 95 divided by 94. Using this calculation, 1 plus this is 25, and FE is already given, that is 5, and if I calculate this whole thing, that will become minus 94. So this will be the magnification. Last question based on this one. Short-sighted person cannot see object distance beyond 20 cm distinctly. What should the power of lens which he should use to seeing distance object clearly? So we can use this formula, 1 by V minus 1 by U is equal to 1 by F. Object distance is minus 2, so 1 by V and 1 upon minus 2, that should be equal to 1 upon Fe. This is the first formula. Second formula, when object is at infinity, in that case what I can use, 1 by V minus 1 by U is equal to 1 by Fe plus 1 by F, the extra lens whatever we are using, and value of U is infinity, so 1 by V 1 by infinity is equal to 1 by F plus 1 by Fe. So using this equation number 1 and equation number 2, if I solve, I will get F is equal to minus 2 and power is equal to 1 by F, so that is equal to 1 upon minus 2, means 0.5 diopter.